we did the old way. And then I'll keep an eye on the waiting room as well.
Okay. Okay, sounds good.
And then
We
Megan, just
could,
whenever you're,
I don't know if this makes sense, but we could disable the waiting room.
Okay, we can do that.
I'll just do that. Okay. So we don't have to worry.
Okay.
sounds good.
Yeah.
All right, it's all yours, Megan.
Okay. Hello, everybody. Welcome to talking about probability today. And to give us a few more minutes to see if anybody else is going to come in, I'm going to play a song. So this was actually created by my dad. He's a music teacher. He teaches kindergarten through 5th grade. And I told him I was going to be teaching a math workshop, and he was super excited. He was like, "Can I make a song for it?" And I was like, "Yeah, sure, why not?" So it's short, it's about 3 minutes, but it's going to kind of play in the background as we wait for a few more people to filter in. So you can let me know if you can hear that. Does everybody hear a guitar? Thumbs up. Let me try sharing it one more time. I think there's share computer sound. Yep, so we're gonna try that one more time.
And then our verses are going to be done by none other than Professor Probability. All right, so hope you enjoy it. And again, thanks so much for taking the time to be here with us and listen to this probability song. Take it away when you're ready, Mr. Feeling. Probability, theoretically, probability, experimentally. Probability is simply how likely something is to happen. Whenever we're unsure about an event, we can talk about the probabilities of certain outcomes or how likely they are. Probability, theoretically, probability, experimentally. Probability means possibility. It is a branch of mathematics that deals with the occurrence of a random event. The value is expressed from 0 to 1. Probability, experimentally, probability, theoretically. Probability is the extent to which an event is likely to occur, measured by the ratio of favorable cases to the whole number of cases possible. Probability, theoretically, probability, experimentally.
Okay, well, I think we are safe to go ahead and get started. And I'm going to, thank you, pin my video real quick. Thank you. Okay, let's make the chat right here. Okay, so to start off, who am I? My name is Megan. I am currently a student at Washtenaw Community College. I will be transferring to Eastern in the winter. I am studying to become a teacher. I would love to become a math or a science teacher. That's just my absolute goal. And then a few fun facts about me is, as you can see in the picture, I actually have 4 pet goats, 2 of which are pictured here. The one on the right is Lilo, and the one on the left is Olaf. And then a few other things. I really love camping. Anytime I can go out, go kayaking, biking, anything like that. The weather's nice, I'll be there. And then another fun fact, my favorite drink is iced coffee or iced chai tea lattes. They're literally my favorite. I can drink them every season. It is just my go-to. So to get started, I thought that I would ask a question. And so that would be, what was your worst travel experience ever? And you can go ahead and unmute yourself and share that, or you could type it in the chat, whatever makes you feel most comfortable. I know it's summertime, so we can kind of reflect on what our past vacations have been. And let me go ahead and pull up my chat. Mexico, okay. Do you have any why was it a bad experience, or was it just overall not very good?
Scary, and oh no, it was awful.
Oh. Okay, well, thank you for sharing. And then if anybody else wants to go ahead and share, I'll wait a few seconds. I would have to say my worst travel experience was when we went up north. We rented a small cabin, and during the trip, it was a really small cabin, and it was like a mile away from the closest bathroom. So it was a hike to go to the bathroom. And while we were there, there was a merry-go-round, and I was playing on it with my friend, and he pushed me off, and my head hit the merry-go-round. And since we were in the middle of nowhere and we had nothing to do, we had to walk like half a mile to a corner store. And we're like, we need help. And then the woman at the counter was freaking out. She was like, oh my gosh. And she ended up calling my parents, and then I went to the doctors and everything. But yeah, that was not a super fun event. And then we can go ahead and go forward. And if you have any other ones, you can go ahead and comment that. But so the plan today is we are going to go through a few things. So first, I'm going to show you guys a video, and then we're going to talk about probability, the different types. We're going to do a few examples. Some are going to be theoretical examples, and then we're going to be doing some experiments. And then at the end, we are going to be playing Jeopardy. And I'll explain that a little bit more as we get to it, but it's going to be fun. And if you have any questions along the way, you can go ahead and comment those, or unmute yourself and ask. So to open up, we're going to watch a short video. It's about 5 minutes. And I like to say, like, what are the chances that this happens? Okay, so let me stop sharing my screen real quick and pull the video up. Okay, let's go ahead and go back. Okay, can everybody see this okay? Is it shared? Let's pull the chat up again. It always disappears on me. I think it was up there. Okay. Well, go ahead and give me an annotation, like a thumbs up, if you can see the screen. I'll go ahead and
Welcome back to our coverage of the game of the year between Yale and North Carolina.
If you're just joining us, we have witnessed an unbelievably well-fought match tonight, and it's come down to penalty kicks. Peterson for Yale, taking the first approach.
Oh, there it is! Spectacular! North Carolina's goalkeeper Richards just let one in past him now, so now the burden rests on Yale's Scott Sterling.
Here he comes, nerves of steel, that man, dealing with more pressure now than a submarine.
Indeed.
Home crowd showing some appreciation.
Johnson places the ball on the spot, getting ready. That man literally has a cannon for a leg.
Yes, he does.
Here he goes, winding up for the shot, and oh! The cannon has fired and hit Sterling directly to the face.
We clocked that at a stunning 116 kilometers per hour.
Now that's a lot of miles per hour.
Little chance that man's nose is not broken right now.
Oh, indeed. Now Sterling getting checked out for that one. Spectacular save, though, but sadly, he's not out of the woods yet.
On his feet now, a bit shaken.
But not stirred.
This crowd absolutely loves this man.
And Sterling's teammates welcome him back, a hero for now.
Yale's up again for the second attempt, looking to make it 2-0.
He approaches the ball with some determination. Here he goes.
Oh,
Oh!
it's high and wide, way off target.
Yes, apparently he thought he was kicking a field goal.
Wrong kind of football, I'd say.
Good show.
Back now to Scott Sterling. He looks a bit worse for wear, but ready for round 2.
And Shaw takes a moment. Here he goes with the approach.
Oh! Sterling with a fantastic dive. The ball flies straight through his hands and once again strikes him straight in the schnoz.
And let's see it again on the old instant replay. Oh, every excruciating detail captured in HD perfection.
Clocked at 129 kilometers per hour. Sterling does not look well.
2 wonderful saves and 2 definite concussions.
They may replace him at this point. He's done all he can.
Yes, as his trainer takes him off the field like a mustached lion dragging a gazelle through the Serengeti.
Adieu, Scott Sterling.
Adieu.
Yale now with their 3rd PK. Richards is in the goal, bouncing like an infant girl.
The crowd holds their breath as he goes in. Here it comes. Oh, very anticlimactic.
Let's see who they got to replace Scott
Sterling is back!
He's still in the game!
Oh my! And he's taking a very odd tactic now.
Seems to be curling up to protect his face.
Not exactly a recommended technique, but here it goes. Wait, no, Lampert needs to tie his shoe. Ho-ho! And that's why you do a double knot, kids.
Sterling still waiting for the kick to happen. He's probably wondering when. Oh! Sweet buttered crumpet!
My
The ball
goodness!
drills Sterling right in the face.
That man's nose must be absolutely devastated. He's gonna look like a witch that flew her broom into her nose and then crashed into a hammer.
I hardly even care about this attempt. Let's go back to Scott
Sterling, the man,
the myth, the legend.
3 perfect blocks by Sterling and his cat-like face reflexes.
Absolutely incredible. Though I must say, Sterling does not look well at all.
Well, you know football players like to add a bit of drama, don't they?
They're gonna take him out. No, wait! They brought him a chair!
Oh, a bold move by the manager.
Indeed.
Bain sets up for the 4th attempt.
And this, frankly, is a gimme. He literally just has to kick it anywhere except where Sterling is sitting.
There is no possible way that North Carolina can mess up this shot.
Oh!
158 kilometers per hour!
This man can do no wrong!
Look at him beg for mercy when it's mercy that should be begging for him!
He has looked death in the eye and said, take your best shot! To which Death replies by punching him in the face over and over and over again.
If Yale makes this final shot, it's all over. But no! Oh, he misses, which means we're going to Scott Sterling!
His face is like a brick wall!
A brick wall that can feel pain and cries a lot.
But where's Sterling? Oh, he seems to be crawling away from the goal. What is he doing?
He's throwing away the bat. Oh! Sterling has done the impossible!
I can't believe it! Look at that! He played it just right! What incredible instincts to crawl away from the goal like that!
And his teammates rush the field, happy as a lark as they slide in.
A Bernini sculpture of a finish!
As his teammates carry him off on the stretcher of glory, we thank you for sharing this absolutely heart-stopping finish.
Scott Sterling and his face of steel have won it all.
Okay, so that was just a cute little video to kind of show in. Go ahead and go back here. Okay, so now that that is over, what did you guys think of it? It is a I love his videos too. They're pretty good. But now we can get back into the workshop. I just thought that was a fun thing to show, just because it's like, what are the chances that would happen? Now, getting into it, what is probability? Probability is the likelihood of an event to or not to occur. So this is the chance of something to or not to happen. So a formula for probability would be the number of favorable events divided by the number of total possible outcomes. So an example of this would be a coin toss. On one side, you have a head, and on the other, you have a tail. So theoretically, if you were to go ahead and toss it, you have a 50-50 chance of either getting a head or a tail, which means you have a 1 out of 2 chance. You one being, let's say, tails out of 2 possibilities. When we talk about probability, the coin and a quarter is a pretty common one to cover. And so we are going to do our own little ratio. And so I would like you all to comment what your favorite music genre is. And so here we have a few selections. Smooth jazz, that might be your favorite. Country, my personal favorite. Techno, pop, or rap. And so you can go ahead and either comment below or unmute yourself. And we're gonna go ahead and do a little bit of a tally. Jazz, okay.
I like pop.
Pop, okay. And then pop, okay. And then I think I am going to exit out of this one. Oops. Didn't mean to do that. Let's go back here. Okay, so there's a way I can add little stars. So we have one for jazz. And we have 2 for pop. Go ahead and check my chat again. I don't know why that's so small. Okay. And then going back to chat here. Okay, I think we only have 3 so far. So if anybody else wants to comment in like the next 5 seconds to put your vote in, anybody is welcome to. Okay, 1 more 4. Okay, so we had a total of 4 people that voted. And so if we had to pick one at random, the chances of picking a student that's their favorite music is pop would be 3 out of 4. And then the chances of picking a student at random whose favorite music is smooth jazz would be 1 out of 4. And then there is one more, and this is just going to be your favorite social media. So of course we have TikTok, we have Snapchat, Instagram, and Twitter. And you can go ahead and comment your favorite choice of social media. None? That's okay. Twitter. Anybody else have a favorite choice of social media? I know it's hard to pick just one. What's your go-to? Well, if I had to pick one, I would have to say it would probably be Instagram. I post a lot on there, so none but Twitter if I need to name. Okay. TikTok. I like TikTok too. It's pretty good. My little siblings got me hooked on it actually. Okay, and so for this one, we had 3 people that voted. So the probability of picking a student at random, theoretically, that their favorite social media is Twitter would be 2 out of 3. And then the probability of picking a student that their favorite is TikTok would be 1 out of 3. And so then let me go back into presenter mode. Okay. And so now we're going to dive into the 2 types so far of probability. So the first one is going to be theoretical. So this is what you think should happen. So in a perfect world, in perfect results, this is what happened with according to the data. So like before, when I said the chance of picking somebody whose favorite social media would be Twitter, that would be in a perfect world, it would be 2 out of 3. So their example here is if a coin is flipped twice, theoretically, it would get 1 head and 1 tail because it's a 50-50 chance. They both have an equal chance of occurring. Now, we don't live in a perfect world, so that involves a lot of experiments sometimes. So another type of probability is experimental data. This is what we will be doing a lot of today. And this is what happens when an experiment is done. So if I flip a coin 2 times and actually do the flips, I could get 2 tails, 2 heads, or a tail and a head. So we are going to talk about a jar of marbles example to look at the difference. And so first we are going to talk about theoretical, and this is what should happen. So in this example, we're going to find the probability of getting a green marble. And so let me share my screen from different one real quick. We are going to go over here. And there we go. So this is a cool little drawing app I found. It's auto draw, so in case you want a drawing pad. And so in this example, we have a jar of marbles, and we have 3 blue marbles, 4 blue marbles, and 2 yellow marbles. So what would be the total number of marbles that we have in our jar? Go ahead and get the chat up again. And then again, you can go ahead and type in the chat or unmute yourself. But we have a total of 9. So theoretically, which is in the perfect world, what would be the chance of pulling out a blue marble? So if I was to reach my hand in there and pull one out, what would be the chance according to this data? Does anybody have any guesses? 4 out of 9? That's close. That would be for the green one. Yeah, for sure. So if we were looking at the green marbles, it would definitely be 4 out of 9. So we can go ahead and write that down. Also tail there. Okay. And then for our blue marbles, 3 out of 9. Yep. And write that down there. Okay, and then finally for our yellow marbles, remember, perfect world, what would it be if we were to reach our hand in and go ahead and pull it out? Two out of 9, perfect. Put a yellow. Okay, so this is our theoretical probability. Like we were saying, this is what should happen. Now we're going to put that to the test, and we're going to see how accurate that may be in our example. Now, it's important to note that in experimental, the given data, the result that we're going to get, is based off of our data set. This is not constant. This is not hardcore evidence. It's based off of a experimental trial. So the more trials that we do, the more accurate that we can get. But today we're just going to do a quick one. And so I don't have a jar. I have a cup, and in this cup I have 9 pieces of paper. 3 are blue, 4 are green, and 2 are yellow. And I'm going to go ahead and shake this up, and I'm going to pull out 9 marbles. We are going to keep track of the colors, and at the end we're going to tally it up to see how it compares to our theoretical. So actually, I'm going to leave this here because we're going to need that. But I'm going to change the colors here and we'll tally it up. It'll work. It'll be great. Okay. So the first one I got is a blue. So I'm going to go ahead and draw a blue line. And then we're going to put it back. Take it up again. Go forward. And we're going to do this 9 times. We got a green. Go ahead and put a green here. Another blue. 3. Got a yellow. I did not have a yellow marker at the time, so I just put a yellow there. Gotta be innovative. This is going to be our 5th one, which is blue. Okay. Almost done. 6 is green. That is not green. Undo that, trying to skew our results. Got green again. So that'll be 2. Green. And yellow. And I believe that is the last spot. All right, so now we are going to take this data set and we are going to make new probabilities. So based on these results, so we go ahead and circle them right here from our experiment, what is the probability that we are going to draw a blue marble? For our green one, yep, we're gonna draw a 4 out of 9 for our green marble. So go ahead and put that here. Okay, and then what about for our blue marble? 3 out of 9, yeah. And then our yellow marble? It's going to be the 2 out of 9. Yep, perfect. Now, if you notice, how does this data compare to our theoretical one? It's actually the same, which can happen. Oftentimes it does not, but like I said, it changes on every other one. I did want to talk to you guys a little bit about some experimental errors. So this could be when I'm doing the experiment, what could come in the way of it? Now in this case, it actually came out like our theoretical, but if it would have been skewed or if it would have been different, what do you think could have been some errors? Maybe something to do with the cup or how I chose to draw the marbles. As you can see, they are paper. Can you think of anything that could have gotten in the way or skewed the results? And again, you can type in the chat or you can unmute yourself, whatever is easiest and most comfortable to you.
The one you pick could always be on the top.
Say that one more time.
The way you put them in.
Yeah, the order that I put them in. Not mix the cup enough. Yep, I could have just kind of went like this. That's just kind of making them go in a circle. It's not really mixing them around. The way I put them in the cup. I'm using paper. I am not using real marbles. Do you think that these can kind of get stuck on each other? I know when I first did this experiment, I'm using a cup now, but I used a paper bag and I was getting yellow every single time. And I'm like, how is this possible? And I looked in the bag and the corners in the bag went up. So all of the other colors filtered in under it and they were hidden. And the only 2 things that I had to choose from were yellow. So definitely it depends on what you're using, how you're using it. And there can be some errors that come into a play that skew your results. So going back over here, we're going to switch gears to our PowerPoint. And I know you guys are going to be like, what's happening? I'm switching back and forth so much. I apologize. So then we just did our experiment. And that was what happens in an experiment. So this is going to be the number of times that what we're looking for occurs divided by the number of trials, which in this case was 9. And going forward, we are going to do another example because we love those. And we're going to do theoretical versus experimental, which is more likely. Now for this one, I have a spinning wheel example that we are going to use, but I couldn't figure out what to put on the wheel. So I decided that I was going to have you guys decide. So I'm going to ask you a would you rather question. You are going to answer the question. Whatever we get the majority of is going to take the majority rolls on the spinning wheel, and whatever we get the minority of is going to take the minority rolls on the spinning wheel. And then we are going to do a theoretical and experimental based off of that data. But to start, I'm going to ask you the question. Would you rather your only mode of transportation be a donkey or a giraffe? And you can go ahead and comment or unmute yourself to answer that question. Get my chat up one more time. Does not appear to want to come up. Go here. Did my chat. Just somehow decided to wait. Oh, there it is. Okay. Let's see. Donkey, giraffe, donkey, donkey. Okay. Giraffe. Got quite a few answers here. Let's see. How many votes do we have for so far? We have 1 for donkey, 2, 3, 3 for donkey, and 1, 2 for giraffe. Okay, so it's gonna look like donkey is going to be our majority. So let's go ahead and make the spinning wheel. And then share my screen one more time. Here, okay. And so this is another app that I found. That's bonus spin. So if you ever want to do this with your friends, if you're deciding what you want for dinner or what you want to do, go ahead and put it on a random spinning wheel generator. Go from there. But we are going to put in our results here. Let's see. And I'm gonna try to mix it up, but we're gonna go. That is nice, blood giraffe. Okay, and so now we have our examples. So we have the majority vote is going to be 4 out of 7 for donkey, and then the minority is going to be 3 out of 7 for giraffe. And so we are going to spin this wheel 7 times and see what we get each time. So without further ado. So the first one is donkey. I'm gonna go ahead and finish it here. And then we will transfer this over to that auto spin as well. One for giraffe. It's the third time. Fourth spin. And then one more. Okay, and so then based on the number of times here, we actually ended up getting 5 out of 7 for donkey and 2 out of 7 for giraffe. So back here. Okay, so again, we use the numbers 4 out of 7 and then 3 out of 7. So we are close with those numbers. We got a little more for the donkey than for the giraffe, but it was close. And so next we are going to talk about how do we use probability in real life. Oh goodness. Let's go through there. Okay, so how do we use probability in real life? So while you most likely won't be performing math problems in your everyday life, you will be making educated guesses based off of the data you've perceived. And so this is when selective probability comes into play. And this is based on a person's own personal reasoning and judgment. So this is the probability that an outcome a person is experiencing or expecting will actually occur. So this could be something like planning around the weather. Maybe you go outside and you don't really check your phone to look at the weather, but you look at the clouds and you notice there's a few darker clouds. So you take the guess that it's going to rain. So based off of your subjective probability, you're like, might as well bring like an umbrella and dress for the weather. This can also be sports strategies and card games. Maybe you get a hand in cards and you're doing really good, and that makes you like kind of play a little more risky moves because you know that you feel that you're going to play and win. Or maybe it's the opposite. You get a really bad hand and you're not going to be as risky and you're going to play it safe because you don't think that that's the right move. And so I do have a short video, it's about 3 minutes, that kind of covers all of these probabilities. It's pretty precise. And let me go ahead and share my screen. Okay. And then let me know if you can share.
We're going to talk about probability, types of probability, and subjective judgment. Probability is just how likely it is that something will happen. We all can think of a weather report where we're told the probability of precipitation is 40%. That just tells us that there's a 40% chance that we're going to have rain or snow during that day. So you can use that to help you plan an activity. If there's an 80% probability of precipitation, you might choose not to go to the park that day because you might get wet. Theoretical probability is when we base a probability on thinking about what the possible outcomes are, and we don't actually do an experiment or see anything. We just think about what outcome am I looking for and how many outcomes are there in total. Experimental probability is when we actually have some observations, we see something happen, we record results, and we figure out from those results how likely it is that something is happening. And subjective judgment is when we base our decisions not on any type of probability, just on our personal feelings. For example, I might look at the weather forecast and see that there's an 80% chance of rain today, but I just have a good feeling about today, and I think that I'm probably going to be all right if I go to the park and it won't rain, even though the probability tells me otherwise. We have a spinner here. If I think about theoretical probability with regard to the spinner has 4 equal sectors. So if I'm interested in the probability of spinning green, I can look at my spinner and I say, you know what? I need to know the total outcomes on the spinner, and I can see the spinner has 4 sectors, 1, 2, 3, 4. They're all equally likely because they're the same size. So the total possible outcomes on that spinner are 4. There are 4 outcomes. I want the probability of getting green. There's 1 green sector. So there's 1 sector out of 4 that is green. So the probability of getting green are my favorable outcomes, 1 favorable outcome, 1 green, out of a total of 4 possible outcomes. So I have a 1 in 4 probability of getting green. I could call that 25% if I would like as well. If I want to look at experimental probability with that same spinner, I'm actually going to spin the spinner and see how many times I get green. So if I spin my spinner, so far I've had 1 spin, no green. So I have 1 spin, no green. Spin the spinner second time. 2 spins, still no green. Spin the spinner a third time. Three spins, still no green. Now my theoretical probability says that 1 in 4 should be green, so maybe I'll get a green this time, maybe I won't. Let's see. Okay, I got a green that time, so 4 spins, 1 green. I'm going to spin it a couple more times, just see how we do here. So now I have 1 more green, no more green, 1 more spin. 1 more spin, no green. I'm going to try for 8 spins, so I've got 6 so far. Let's try for 2 more. I got 1 green. And I got 1 more green. So I can see that my experimental probability, out of 8 spins that I did, I got 3 green. So my favorable outcomes were 3. 3 outcomes were green out of a total outcome of 8. So I didn't get exactly the same as my theoretical probability of 1 in 4. because obviously 2 out of 8 would be a 1 in 4 probability. I have 3 in 8. We know that the more often I do the experiment, the closer I will get to the theoretical probability. So if I was to spin the spinner 100 times, I would get very close to my 25%. Subjective judgment doesn't rely on probability at all. It's just something like, I think the next spin will be red because that's my favorite color. Or I think the next spin will be green because it's St. Patrick's Day. So it's got nothing to do with actual probability. It's just got to do with your own feelings. You might have a hunch or something like that. That's subjective judgment.
All
I
right.
need to find.
And then that is all I have for there, which means that it is time for. And so, has anybody here played Jeopardy before? Do they know kind of an idea, just idea what it is? Yes? Okay. Awesome. And so the way we're going to do it is you can say, I know the technical rules when you answer a question is like, what is, and then you answer it. However, we're not going to do that just because I know sometimes we get excited and we know the answer and we're like, yes, I know it. And then you say it. So if you want to say it, you can go ahead and say the technical rules before, but you're not going to be penalized if you don't. So I put together a Jeopardy board. And it is going to have 3 categories. And so how that we play this is going to depend on what you guys want to do. If you want to do teams, if you kind of just want to go for it, what are we thinking? Split people up into teams, just everybody kind of go for it at once and we pick different categories and try to solve it. You can go ahead and comment your
Yeah, I think it would be more fun if we just go everybody against each other.
Okay, yeah, we can do that. All right, so let's go here. We're gonna set it to no teams and let me share my screen so you guys can see what I'm doing. Okay, and so we are going to hit start. And of course, it would not be Jeopardy without the music. So we are gonna go to our soundboard here and play our intro.
This is Jeopardy!
Okay, so we have 3 categories here. We have theoretical, experimental, and mystery. And like the name suggests, it is going to follow kind of what we covered, and it's going to have to deal with the things that we've talked about. So with that being said, do we have a category that we want to start with or a number we want to start with? You can just go ahead and throw it out there, and we will kind of quickly go through it as we go.
Experimental.
Okay, what number? You have 100, 200, 300, 400, or 500?
300.
300. So, what is the probability that in a family of 3 boys and 2 girls, the 3 boys were born in succession? And so for these ones, these are going to be our fun ones because we are going to do an experiment. And so here we have a cup kind of like before, and it has 3 boys and 2 girls. So there's the letters here. And we are going to draw 5 out and see what are the odds that they're born in succession. Shake it up, pull one out. And we have a B. So there's 1 boy. Need 2 more. Another one. We have a girl. Here we have another B. Girl. And the last one is going to be a boy. So So in this one, it went every other. We had a girl, boy, girl, boy, girl, boy. And based on this experimental data, we didn't get anything. So the probability would be 0 out of 5 because we did not get the 3 boys and the 2 girls in the succession order. And so we're going to go ahead and go on to a next one. So the theoretical, experimental, or mystery. I will say a hint, the experimental, we're going to be doing a lot of experiments. So if anybody-
Theoretical.
Okay, and then what number? 100, 200, 300, 400?
400. I'm going for big money.
Okay. Okay, and so for this one, we have a box contains 7 tickets numbered 1 through 7. What is the probability of obtaining an odd number? So you go ahead and shout out your guesses or comment them.
4 out of 7.
Out of 7. Go ahead and hit the space bar. Answer is 4 out of 7. Correct. The big money was 1. So the odd numbers that were laid was 1, 3, 5, and 7. Anybody else have one that they're looking for? Feel good about? Mystery 100. Okay. And this one is a question. What is probability in your words? You can go ahead and type it or unmute yourself and answer it. And it does not have to be a long, drawn-out explanation, just a basic summary of what you believe probability is.
How likely something is to happen?
Yeah, perfect. How likely something is to happen? The chances for an event to occur or not to occur, perfect. How likely something is to happen? And then just the answer here. Probability is the likelihood an event to or not to happen. The chance, another answer would be the chance of something to or not to occur. Anybody else? More guesses?
Mystery 300.
Mystery 300? Okay. All right. What is experimental probability? So in your words, what do you think experimental probability is? A quick summary. Maybe I need to get my
That's when you actually try it.
yeah, when you are making a trial, so you're doing an experiment and you're trying to figure out what the data is based off that experiment. Perfect. And then just another way to phrase that too would be what happens when the experiment is done according to that data as well. Okay. Next one. Anybody have any guesses? Feel something good about a certain one? Play my Jeopardy theme song in the background. Anytime anybody has one, just go ahead and jump in it.
It's the
You ready?
400.
All right. Okay, so we are going to go ahead for theoretical 500. So a box contains 7 tickets numbered 1 through 7. What is the probability of obtaining a prime number?
Oh, 5 out of 7.
5 out of 7. Let's see. Very, very close. So 4 out of 7. So the prime numbers.
Oh, yeah, I counted 1. Yeah, I counted 1. 2 is starting with primes.
I do that too. You're good. You're good. So then the prime numbers that we use were 2, 3, 5, and 7. So out of the 7 numbers that we had tickets, 4 of those would be prime. Okay. Going back here, does anybody else have any other ones that they were looking for?
Mystery 200.
Mystery 200? Okay. What is theoretical probability? So in your words, in your summary, what do you believe theoretical probability is? A good definition for that.
Is it when like in a perfect world, you would pick?
Yep, absolutely. So this is in, let me go ahead. In a perfect world, what you think should happen. So this is according to the data, you have the numbers, this is how it should go. Okay, just a few more. Anybody else?
Mystery 400.
Mystery 400. Okay, what is subjective probability? So again, in your words, what do you, how do you define subjective probability? Guessing according to life experiences. Something happens based on my experience. Yes. So subjective probability isn't really probability. It's based on a person's own personal reasoning and judgment, which, as we know, can have errors. Like you were saying, Victor and Susan, that it's based on your experience, your own life experiences, not really data. Perfect. Okay. Just a few more counting down. We have theoretical, 3 categories left, experimental, 4 categories left, and mystery, there is 1 more category left.
Mystery 500.
So Andrews flipped a coin 50 times and tallied 15 heads and 35 tails. He asks you why he's not getting 25 heads and 25 tails, because you said that the probability of heads is 1/2. How would you respond to the situation? And I'll go ahead.
I can say because it's an actual experiment, and the probability when you perform the experiment doesn't necessarily is the same probability as the theoretical probability, unless you do the experiment many times.
Yeah, that's a really good answer. I don't think you can limit it based on a certain set number. Maybe Andrew didn't flip these as many times as he could have. He just kind of flipped them a few and then he got tired and was like, you know, we're gonna go based off of these datas. Needs to be flipped more times for it to be closer to half. Yeah, absolutely. Is there any other guesses? There's a couple ways you can interpret this problem. This is one based kind of how you would respond to somebody, like either a student, classmate, and it can be interpreted a few different ways.
Coin may not be a coin.
Coin may not be a fair coin. Yeah, it might not be a fair coin. Maybe it has heavier on one end or not heavier on another. And let's go ahead and go here. So the answers to this, like I said, they may vary. Something that I would tell the student, Andrew, is that coin tosses are independent. So the probability of getting heads based off one coin toss is 1/2. And so that doesn't mean that you're going to get tails half of the time and heads half of the time. It means based off of the one coin toss you do, you have a 50-50 chance. Not going to be 50-50 every time you do it. But those are really good answers, and I really like them. I like the coin toss one. Sometimes coins there. All right, and we have mystery is all done. So we have theoretical and experimental left.
Theoretical 300.
Go ahead and say that one more time.
Theoretical 300.
Theoretical. Okay, A bag contains 4 blue marbles, 5 orange marbles, and 3 green marbles. What is the probability of selecting a green marble? Can this number be reduced? So I'll give you guys a few seconds. And this is going to be very similar to the problem that we did earlier. If anybody had any guesses? We had a 9, 1, 3. Yes. Okay. Gonna go ahead and. So the green marble, if you add them all together, the 4, the 5 orange marbles, and the 3 green ones, I know it can get tricky with all the words. This is a long one. You're gonna get 12, and then if you take the number of green marbles, that would be 3. So then in total, you would have 3 over 12, and that can be reduced if you divide both of those by 3. So if you divide the top and the bottom. Susan, I messed up. I didn't add correctly. I do that all the time. I have to slow down. I get so excited. No worries. And then good job, Victor. Yeah, 3 out of 12 can be reduced to 1/4. Perfect. Okay. And then we are coming down to the countdown. There is just a few categories left. Everybody seems to be a little weary of the experimental. I promise they're fun. But go ahead and shoot out.
Experimental 500.
Experimental 500. I like it. I like it. Okay. So a card is drawn at random from a deck of cards. Find the probability of drawing an ace. Hint, there are a total of 52 cards with 4 suits. So that means out of the 52 cards, there's going to be hearts, diamonds, spades, and clubs. So think about that carefully, what that means for the card that you're looking for. And this one is not an experiment. We are just going to have to do it. But I do have a picture of a layout of cards if that would be easier. So if anybody wants to see that, I can pull that up as well. Yes, absolutely. So let's go here. The answer is 4 out of 52. Good job, Victor, which can be reduced to 1 out of 13. Yep, I made an error on that. You are completely right. So how I got this is going to be, you have an ace of heart, ace of diamond, ace of spade, and ace of club, which is going to be 4 out of the 52 cards, which will be reduced to 113. Okay. And then do we have any other ones that we're looking for? Jeopardy game is so cool. I like it. I think it's fun too. I like probability in cards. Yeah, I like probability in cards as well. Experimental 100. Okay. So a spinner has 5 sections labeled A, B, A, and B. What is the probability that the spinner will land on B? Now, if we were talking theoretical, that would be 2 out of 5, but we are going to be doing an experiment. So I'm going to go back to the spinning wheel example, and we're going to go ahead and put that down again. And can you guys see the spinning wheel here, or should I reshare my screen? You can see it? Okay, that's it. So we got A, B, A, B. 1, 2, 3, 4, 5. Okay, and we are going to spin this 5 times. You need a double Jeopardy. Okay, so the first one we got is A. B. this will be the last time for 5. And A. And so in here we got, let's see if I can write here. So for A, we ended up getting 2/5. You can ignore that on the board. And then for B, we ended up getting 3 out of 5, which is pretty interesting because when we did the theoretical, B was the one that was supposed to be less. Okay, only 4 more. Speed count round time. Do we have theoretical or experimental? Which ones are we thinking?
Experimental 400.
Experimental 400. Okay. A baseball player has a batting average of 0.300, which means that on average, the player gets 3 hits and 10 times at bat. What is the probability this player will get at least 3 hits in the next 5 times at bat? So this is our last cup example. And so for this one, in here, I have 3 pieces of paper that have the letter H on it. And I have 7 pieces of paper that have the letter M on it. And so we are going to draw 5 out and see that if we can get 3 of the H's, because they're looking for the next 5 times at bat. So we have first is a miss. And in this one, the order does not matter. It says just at least 3. Miss. The boy-girl example was a little bit harder because it's said in succession. Another one. So we're at 3. 2 more. We have a miss. 1 more. And a hit. So he got 1 hit out of 5 times. That was not 3, but he did get 1. For that experiment. Now, the last 3, getting close on the end here.
Theoretical 200.
Theoretical 200. Oh, sorry, I clicked the wrong one. We are going to exit that. A box contains 7 tickets numbered 1 through 7. Don't you love this question? What is the probability of obtaining a number less than 5?
Four out of 7.
4 out of 7? Absolutely right. So the numbers that are less than 5 in here would be 4, 3, 2, and 1. Good job. Okay, the last 2. Victor, yes, 4 out of 7. Okay, we have 1 more for theoretical and 1 more for experimental.
Experimental 200.
Okay. All right. 2 coins are tossed. Find the probability that 2 heads are obtained. Note, each coin toss has 2 possible outcomes, a head and a tail. And so for this one, ooh, that's not supposed to see the answer, but we're going to do an experiment. We're just going to hide that answer there. So if we have 2 coins and we toss them, this one, I got a head. You can see that? This one. I got the head, actually. Pretty cool. What? Okay. But the answer to this would be 1 out of 4. And the reason of that being is each side has 2, so there's 2 chances, which means that we could have 4 different possibilities. We could have got a head and a tail, a head and a head, a tail and a head, or a tail and a tail. And out of those possibilities, there was 1 that got both a head and a head. Okay, and then the last one is going to be our theoretical, the 100. And this is, what is the probability of getting a tail on a coin toss? Single coin toss.
One out of 2.
1 out of 2. You are exactly correct, and that is perfect. 1 out of 2. Yep. Perfect. All right. And that completes our Jeopardy game. You guys did great. I'm so proud. And that is actually all that I have for you today. I hoped you enjoyed the probability workshop and hopefully learned a few things. Maybe you learned a lot, maybe you learned a little, but that's okay. I'm glad you all came and thank you so much. Thank you. Thank you. Yep. And then you all are free to go. That's the end of the workshop unless you have any other questions, and you can stay and ask those as well. So thank you again.
Very cool. Thank you. Thank you.